Hello dear student, welcome to my YouTube channel. In this video we will see resonance effect. So like the video and subscribe the channel for more updates. So the resonance word, simply if we talk about a resonance, so resonance it is like there are more structures of an same molecule. So resonance occurs when a molecule can be represented by two or more structures differing only in the arrangement of electrons without shifting any atoms in the region involved. The delocalization of an electron. What is that delocalization? So we will understand. Resonance structures are not an actual structures of foreign molecule. They are non-existent and hypothetical structures. Resonance structures are interconvertible by one or by a series of short electron shift. For an example, say this, it is the structure of an benzene, and here you can see now there are some more structures of an benzene that I will show you. So when it has been represented by two or more structures, so there are two or more structures differing only in the arrangement of an electrons without shifting any atom. So atom means here carbon, hydrogen, they will be at their position. Only there is a delocalization of an electron. Delocalization means electrons can be there is a movement of an electrons, and localized electrons means there is no movement of electron, and delocalized means there is movement of an electron. So movement of electron here it is like there are some sigma bonds and there are some pi bonds in between the carbon and carbon. So all the single bonds they are sigma. So they are sigma between carbon and carbon, and double bond all they are pi bonds. So all these three are pi bonds, and there are 6 sigma bond between carbon and carbon, and total there are 12 sigma bonds. Like in carbon and hydrogen there is one more sigma bond. So this 3 pi bond and pi electrons they get delocalized. It means now when we are showing the arrow, it means that electron it has been shifted on the next carbon between carbon and carbon. Here the electron again it has been shifted on the next carbon and carbon. So it continues in the series. So there is one more structure of this benzene. Now we can see this carbon-carbon double bond, it has been shifted here. So there is now a new bond formation, and the carbon-carbon here, the double bond, it has been shifted to the next carbon and carbon, and we can see the third sigma bond. So not sigma, it is an pi bond. So it has been shifted between carbon and carbon, and now here again it is new. So this series continue. So it has been shown by a double head arrow. So double head arrow, it means these are resonance structures. Resonance means they are interconvertible. First thing is that, and there are two hypothetical structures of it, and the actual structures of this benzene ring, it is as such that electrons are been distributed in a hybrid form. That is, and this it has been confirmed by spectroscopic studies also, that the distance between carbon and carbon, each carbon, it is similar in case of an benzene ring. So it as such, when it is in sigma bond between carbon and carbon, the distance should shrink. When it is a pi, it should be lengthier, but it has been confirmed by spectroscopic studies that all the carbons they are having a similar distance. It is due to this hybrid structure. It means that electron density it has been distributed all over the carbons. So these are two hypothetical structures, so they are non-existent, and the actual structure of an benzene we write it is in. So this it is an equivalent structure for this both bonded structure. So we can write benzene with the ring. So this is said to be a resonance of a molecule, that when there are two or more structures, and when these two or more structures they involve in delocalization of an electrons without changing any atom or shifting any atom, so such thing is said to be a resonance. Resonance hybrid represent the actual structure of a molecule. So as I have shown the third structure, that is ring in ring benzene, and it in between it is having a ring. So that is a hybrid structure. So this hybrid structure it represents a molecule. The structure of resonance hybrid is an intermediate between various resonance structures and is a mixture of them. Resonance hybrid is represented by double-headed arrow. So as we have seen that double-headed arrow, as such, this it is a double-headed arrow for showing and resonance structures, and there should be no confusion between the two arrows. They are utilized for an equilibrium. So these are the two arrows, they are utilized for an equilibrium. When the structure it is interconvertible, so it can be shown by this way, and this it is by for an equilibrium type of an compounds. A resonance hybrid is more stable than any of its contributing form. So this form like of an benzene, and it is having a ring in between, it is more stable than any other structures which is having a bonded structures. And as the resonance increases, stability of the molecule also increases, and it lessens the reactivity. So reactivity it is reduced when there are more resonance structure. As the number of resonance structure increases, so stability will also increase, and as the stability increases, its reactivity also decreases. So thank you for watching the video. If you are having any doubt about resonance, you can comment me in the comment section. I will definitely answer it.